Run modes. For run modes, I want to use a little analogy here. Running means I'm running code. Simple enough. We have low power modes where I'm not running code. But these are different modes we can configure for running different parts of code. So I need 3 volunteers. How about you 3 guys front row? What's your name?
Doug.
Doug. Okay. Doug, let's say you want to write an analog task and you're going to be the analog guy and you are the only one running most of the time, and you're just going to be looking for certain thresholds, okay? So that you just need a slow clock. And when you see an analog value that exceeds a certain boundary, you're going to activate somebody else to do something. And your name is? Ethan. So Ethan, when you start running, you're going to look at what Doug sends you and says, oh yeah, these are out of bounds, I better tell somebody. So you're going to use a CAN network here to a couple CAN nodes to transmit to some other processor and say, hey, are we okay, or should I just tell Doug back to go back to do your analog stuff? And for you to run though, you need clocks to different peripherals. You have to activate the CAN module, and you want a crystal running because CAN doesn't like sloppy clocks. It likes crystal clocks. So you want the crystal, but you really don't need 64 megahertz PLL because we're running slow. Okay? And what's your name?
Josh.
Josh. So depending on what your communication task does, Doug, comes back, you may get the message from some other processor, maybe Lydia in the back, that says, hey, you better get everybody up, you have to do something. So Josh, he's going to be full control. Josh wants all those peripherals up and running, and he wants full 64 megahertz clock. So that little scenario here I put on a slide. This is my analog, this is Doug, and this is Ethan, and this is Josh, okay? So Doug, for the analog, needs this peripheral and this clock, okay? Ethan needs these 2 CAN modules and this clock, and Josh, he needs everything 64 megahertz. So we want to be green. What we want to do is only turn on clocks that we need, and this is key because the modes is what's different than what you've had in other processors. And so showing the logic here is just key to understanding the registers that you'll be configuring. So there are 2 tables here, and this top table shows our tasks: analog monitoring, our communication task, and the whole chip. And what I need for a system clock is the 16 megahertz here. Here I need the crystal, and here I need the PLL. And out of reset, I have this running already. But the crystal circuitry is turned off and the PLL is turned off. So those will have to be turned on. And so I have a configuration here where I've specified here the crystal has to be on here for run 1 and run 2, because I'm assigning numbers here to these running modes, run 0, run 1, run 2. And the PLL has to be on for this run 2 where I have the whole chip. So these are mode configurations. I'm calling this, we have actually 4 run modes, 0, 1, and 2, and 3. I only need 3 here. You may just stick with run 0 and put everything there and forget about it. But this is the intent, is to be able to only use the clocks that you need. But it's not just clock sources for system clock. It's also peripheral clocks, because here's another unique thing that maybe you didn't have before. Out of reset, none of those peripherals have a clock. And I guarantee you, at some point, you're going to start the debugger and you're going to write a register value to maybe the SPI, and then you're going to look and it's not there. And the reason it's not there is because you haven't given it a clock yet. So we're going to have to set up a control for these peripherals where it has a configuration to get a clock for that particular mode. And we can give clocks to peripherals on a mode-by-mode basis. So on this little table here, I wrote down, okay, when I'm in run 0, I need a clock to the A to D controller, and I also need one to the system integration unit, because all the pads have to be specified that, hey, I'm going to be used for the A to D, or I'm going to be used for CAN, etc. And here, for the communication, which is my Run 1 mode, I need clocks for these peripherals, the CAN and the SIU. And here for Run 2, I need clocks to everybody. So I configure clocks for these on a run mode basis by each peripheral has its own peripheral control register. It's a certain number. And the control register then will select a particular peripheral configuration. And this is just a table I built from up above here. The A to D has to be running in Run 0 and Run 2. CAN has to be 1 and 2. SIU and 0, 1, and 2. All others have to be in Run 2. So I've actually got a configuration, and there's only a few configurations you're going to have. So there is a run mode peripheral configuration register. And I'm going to specify to the A to D, use run peripheral configuration 0. The CAN modules, I want to use the run peripheral configuration 1, which will have these run modes, etc., all the way for the others. So these are good places to start to understanding modes. All I'm trying to do is saying, when do I want clocks to go to peripherals? Now, we talked about run modes. These are user modes. We talked about 0, 1, 2, 3. There's also some low power modes that I'm not going to go into, halt, stop, and standby. And then there are system modes, like during reset, we're in the reset mode. You don't do anything. But after reset, we are in the default run mode. We can execute code here in this. And you will, when you get to main, you're in this default run mode. This is where you set up your configuration for your run modes. And all the examples do this for you. It's not a lot of code. It's not too bad. And then we have a safe mode. This is in case there is a hardware failure. Let's say John, who was talking earlier, he's kind of a practical joker. He's, marketing kind of guy. And let's say Lydia is working on her Bolero board and she's got it running that she thinks good. So Lydia goes to lunch. And John says, it's April Fool's here. While she's at lunch, he takes the crystal off the board and puts it back, So, but the code was running at the time. So this is a hardware failure. But you can recover. And what happens is the hardware automatically takes you into a safe mode. You execute code. So now you can detect that you're in the safe mode and check to see what the problem is. I think for this competition, you won't have to worry about safe mode, but this is the purpose of it. And there's a test mode. That's for fact. That's not for you. That's for us to use. And so that's all the modes. So for each of these modes, we can specify these system clock sources. Are they on or off? What am I using for system clock? And for low power modes, I have other stuff I can turn off. So here's a little state diagram of the modes. Out of reset, I'd go into my default run mode. I set up my configurations. Then I transition into run 0, 1, 2, or 3. If I use low power, I can go to those modes as well. And but normally, out of reset, I go into D-run. I do some initial mode configuration. I set up my clocks. Then I run, and this is where my application goes. And maybe you only need run 0, and that's it. Okay, so the registers for these configurations. We have mode configurations registers. And our naming convention is, before the underscore here, we have the module name. It could be a SPI module, it could be A to D converter module, it could be SIU. This is the mode entry module. And then for the default run mode, the D-run mode, there is a mode configuration. This is just an example. And this is what's in there. So here are the controls to turn on the clock sources, the oscillator, the PLL, the IRC, and then I specify system clock. For run modes, that's all I need to worry about. And these just leave alone, leave these on. I found it handy at least to kind of keep track if I'm going to have different modes and build a table. And all the examples in the application note, the MPC 5500 and 5600 Simple Cookbook, all of these examples for the Bolero have this table in here where I just keep track of out of reset. I'm in this derun mode, and the configuration for that is in this register, and the system clock is this, and these are the clock sources that are on, and these are the other things on or off. And then I want to use the run mode 0, and this is my system clock, and these are the other clock sources and other resources that are on or off. So if I'm having multiple modes, that's a good little chart to have. So this will get me up and configured for running off the PLL. I still have to, the PLL has a formula, so I'll set the register values for that formula. Now the peripherals though. Okay, I've turned off the slide just to get your attention for a minute. Out of reset, none of the peripherals have clocks. So I mentioned that before, but I just mentioned again, we have to configure the peripherals to have clocks. And we're going to do that using these peripheral control registers. And each peripheral has a number. The SPI, for example, is 4, SPI 0, SPI 1 is 5, SIU 68. And these registers inside will have a number that you specify for a run configuration. There's also low power we're not using, but it'll just have a number to specify which of 8 run configuration registers I'm going to use. And this is a run configuration, peripheral configuration for the run modes register. So I'll set here what run modes I want to use. So these are the enabled modes here that I want to use using this peripheral configuration 1. Probably what you want to do is just, like I said, start with the example and then as you add peripherals, just use the same peripheral configuration for all of them.